our laboratory is really a basic research laboratory, but we've been interested in cancer for a number of years. And we've been trying to really zero in on what we would say are the unique vulnerability of cancer cells relative to a healthy normal cell. And among those unique vulnerabilities are they use specific metabolic enzymes to satisfy needs normal cells don't have. And so we've been developing drug candidates to try to hit at those vulnerabilities. And it struck me that there were similarities between how cancer cells continue to evolve and become malignant, and particularly things they need, and what virus-infected cells start to become. And they share the vulnerabilities in terms of many of these metabolic activities. So it started to occur to us that the same drug candidates that we've been developing for some time to target cancer cells in what we were hoping is a unique way, we could use to target virus-infected cells. So all that led us to start thinking like virologists, even though I'm not a virologist. When a virus infects a cell, it has to basically take over the cellular machinery to make more viruses, which eventually will kill that cell, but then the viruses are spit out and they infect other cells. And so we want to be able to target the proteins that viruses need, just like cancer cells, to take over the machinery. So they have to use metabolic enzymes that normal cells typically aren't using anywhere near the same extent. And those are the vulnerabilities. If we can target those activities, those proteins, with the right drugs, then the virus can't take over the host cell, or at least can't reproduce itself. And so what we want to look at is we want to look at our drug candidates, how they bind to these proteins, to these enzymes in 3 dimensions. Then we can say, okay, here's what we want to tweak. There's where we really want to intervene. And we know something's going to be, this isn't going to be the end. There's going to be another wave. There's going to be other viruses. And so I think, for us, a lot of what we've been doing in our laboratory for the last 10 years, we can see how we can turn it towards actually addressing very similar questions using very similar approaches against virus infection. But we need that structural information that we can get at CHESS to be able to help us design better drugs.